My name is Michael Goldberg, and I'm the founder of CivicSolar. We started the company in the winter of 2009 with a single mission of accelerating the adoption of solar power by serving as the most responsive and reliable distributor in the solar industry. Today, a decade later, we have 3 office locations, regional warehousing, 70 dedicated solar professionals, and we are proud to serve 3,500 contractor customers throughout the Americas. It is my pleasure to welcome you to this S5 webinar and the opportunity to hear and learn from a legend of the roofing industry and the founder of S5, Rob Haddock. He has a background of 18 years of contracting in the metal construction industry and 35 years of technical writing, standard creation, education, and forensic consulting within the metal roofing community. His lectures and writings on metal roofing topics has been translated in 8 languages. S5 has a track record of 27 years and over 2 gigawatts of successful solar mounted on metal roofs all over the world, including Google headquarters and most of the largest metal the solar industry at the same time. With that, I'd like to pass you over to Rob Haddock. Thank you.
Thank you. Thanks, Michael, and it's good to be here. I have to admit this is a little unusual for me because I'm usually talking to a live audience and I can see people's smiling faces and tell when they're going to sleep and need to jazz it up and that sort of stuff. So this is a little different venue for me, but I'm real happy to be here with you. I got a slide advance. You've probably seen these kind of disclaimers before. What this says in short form is that all the stuff you're about to see is owned by Metal Roof Innovations, S5, and to reproduce any portion for any other purpose without written permission is forbidden. Having said that, I'm not too awful fussy, and if you contact me, if you do have some reason you want to reproduce any of this, contact me and we'll talk about it, and normally I will grant permission. This is a little bit about me. I'm not going to bore you with reading through these bullet by bullet, but what I do want to emphasize is that my career has been spent for about 47 years now in the field of metal roofing. So we didn't start this company to get in the solar mounting business. We were actually in the mounting business. Going clear back to 1991, we invented some unique technologies for being able to attach all kinds of things to standing seam roofs. So we were already in that business for a good number of years before the solar industry got cranked up. And the solar industry sort of found us because we had a lot of patented technologies that made it easy to install things, including solar, onto metal roofs. The first thing that I'm going to give you a little bit of an education about metal roofs in general, and then we'll get into more specifics about mounting techniques on metal roofs. But the first thing you need to know is that metal roofing is not something new. It's been around for about 3 millennia, and there are many structures that still exist. You're looking here at Dome of the Rock in Jerusalem, which was built like 1,400 years ago following the Arabic conquest of that city, and many other applications throughout Europe and the Middle East, and in truth all over the world. It's not a new thing. Interestingly, the very first recorded history that I see of metal having on top of the Jewish temple ruins, Temple Mount as it's called, in the very first recorded history I saw of metal being used as a roofing material is actually in the book of Kings and 2nd Chronicles. It was Solomon's temple. So Solomon's temple, the way I read scripture, was also having a metal roof clear back 3,000 years ago. That was about 970 years BC. And it's still a favorite choice today. Here you see IBM's world headquarters, NATO's world headquarters, National Renewable Energy Lab world headquarters here in Golden, Colorado. And Apple Park, which is certainly one of the largest rooftop solar arrays in the world. It's on a metal roof as well. So all these very highly visible brands have used metal roofing for a good while, and many, many others. These are just some particularly notable ones. And of course, it's used in residential applications as well on millions of homes. Metal roofing is about 31%, that's this year's figures, year to date, of the commercial industrial roofing market as defined by FW Dodge. And in these type applications, metal roofing, as you see in this slide, is often installed over open structural framing. It's structural roofing, so it's able to carry loads from support to support. And it's about 13% of the residential roofing market. This also is a figure from as of year end last year, 2018, is published by the Metal Roofing Alliance. In these kinds of applications, many standing seam and other metal roof panels are installed over solid wood decks, as you see here. That's rather typical of residential and light commercial construction. In total, well over 2 billion square feet of metal roofing are installed in the U.S. every year, and it's been that way for at least the last 4 decades. And that is a growing trend, so that number escalates year by year. What that means is there's a lot of it out there. You don't see metal roofing a lot because in many cases the applications are in very low slopes, as you see here in this slide. So, you know, people tend to think, well, gee, there isn't that much metal roofing around because they're looking at steep slope roofs that are mostly residential applications. And metal only occupies about 13% of that market, which is also a growing figure. But industrial and commercial, larger projects, it's used quite extensively, more so than any other single roof type. Metal roofing is quite sustainable. The Galvalume, I trust that many are familiar with the term Galvalume. That's a coating on carbon steel sheet. And that was introduced to the marketplace in the late 70s. And the Galvalume standing seam roof is now proven to have a service life between 60 and 70 years. So coated steel roofs have a service life of over 60 years. Well, what does that mean to us? What it means is that we can still install solar on a roof that's 30 years old and never have to replace the roof during the life of the solar. So there's an enormous inventory of metal roofing out there, and that's why it's important to know and understand something about it and something about mounting solar on it. Metal roofs, by the way, are also environmentally friendly, as you see in that last bullet. They're 100% recyclable, and they actually make economic sense to recycle. In other words, it's a profitable industry to recycle metal roofing. There are 2 primary categories or types of metal roofing. The first is what we call standing seam. And standing seam profiles will always use concealed fastenings for their attachment to the building structure. So how do you know when you're dealing with a standing seam roof? Well, if you go up on the roof and you don't see any exposed fasteners, it's going to be a standing seam kind of profile. And our company, S5 Attachment Solutions, has a clamp for any and all of the commercially available standing seam profiles that we're aware of in North America. This was our original technology, was was gripping a seam with a clamp, as you see in these diagrams. And I invented that technology back in 1991, patented it in 1992. S5 is a very innovative company, and we've since come up with other attachment methods that are technically correct for attaching to other roof profiles as well. In fact, in total, we've been awarded, I think, 56 patents to date. Some of the original ones from back in 1992 have expired, but we still have some 40 plus that are active patents. Now, standing seam profiles are of two varieties. In the first case, they're snapped together seams, as illustrated by this quick video, where the male and the female components of the seam just snap together in the field. Installers tend to prefer these because they're easier to use than their counterpart, which is a mechanically seamed profile. Mechanical seaming tends to be more durable with respect to its performance under wind uplift pressures and so on. There you see a seaming machine that's closed and finished that seam. The second major category of metal roofing is called screw fastened or through fastened or face fastened. All of those terms are synonymous, meaning that we screw through the face of the panel, through the weathering membrane with a gasketed screw or other type fastener. So these profiles are what are generally also termed exposed fastened or exposed fastener profiles. All these terms here on this slide are synonymous. And how do you know if you're dealing with an exposed fastened roof? Well, if you go up onto the roof and you see a multitude of fasteners holding it down to the structure, it's an exposed fastener roof. So having dichotomized those two major categories of metal roofing, let's get into the methods that are used for mounting to each of them. There are three basic methods for mounting to any metal roof, and all work with S5 attachment solutions. The first is tilting modules to get them to their optimal sun angle. And while that was very popular 10 or 12 years ago, as module costs have fallen and the cost of installed solar has fallen, in today's market, the premium cost of tilting is not too often justified economically. And so we're seeing a migration over the last 5 years or so to mounting modules planar to the roof, regardless of the roof slope, and just adding more modules, which proves more economically effective in many cases. So the second mounting method is planar to the roof using a linear rail. I'm sure that you all are familiar with rail attachment. And the rail is then attached to the metal roof with specialty clamps or brackets, hopefully S5 clamps or brackets. When rail mounting to standing seam, we use a clamp. And as I said earlier, this was a rather revolutionary technology that was invented by S5 in 1991. Because there are many different seam profiles out there, we have a clamp selection tool on our website that'll help you choose the specific clamp to properly fit and achieve the maximum holding strength on any individual profile. Simply go to our home page and click the Learn More button, or go to the Resources drop-down menu at the top of the screen and select the clamp selection tool. And that'll give you some handy tips and graphics as to fitting certain S5 specific parts to specific seam geometries. When rail mounting on face fastened profiles, S5 has 4 different options to attach rails. The first one attaches to sheet only, and the other 3 to structure. So we'll take a quick look at each one of them. There are some features and benefits to each one of these components that make them different from the next, and you get to choose what your preference is. The Protea bracket works with either a side or bottom mounted rail. It can be used in either axis. It is height adjustable, requires no L-foot, as you can see in that image. The L-foot is part of the component offering, and that L-foot will turn around different ways. For you're looking at it in a bottom mount rail orientation. You flip it over and it works in a side mount orientation. As I said, it's height adjustable. No L-foot required or recommended. If you stand an L-foot on top of what you see in this slide, you're creating a moment arm. You're getting that moment arm so high that our tested holding strengths become invalid, because we don't test our parts that way. The next part is a solar foot. So if you're wanting to, the advantage to the first one, the Protea, is that you can attach anywhere along the rib or seam of the roof. With the solar foot, you're attaching in the flat. This is a structural only attachment. It goes through the roof and into the structure, and it's compatible with any domestic rail producer's L-foot. In fact, any L-foot sold in the world that we're aware of. And it will mount rail in either axis on the roof as desired. The M8 nut isn't shown in that image, but it is included with the part. And as I said, it must attach to structure, and that's the way it's tested. Is height adjustable, and no L-foot is required with that part either. It sort of melds an L-foot with a solar foot all in one part for side-mounted rail. It again mounts to structure. And the last one is the VersaBracket 47. We also have a little bit taller one, which is called the VersaBracket 67. And this is for bottom mount rail only. Again, it can be used in either axis on the roof. It's not height adjustable. And once more, no L-foot is required or recommended. And it also attaches to structure. All these components have factory applied sealants that are tested in assembly to ASTM 2140, which is a static water test. It's like a fishbowl test, where the joint of the S5 part to the roof itself is submersed under a minimum of 5 inches of static water head and held for 5 hours. If it leaks a drop, it failed. And those sealants are the same kind of sealants that have been used within the metal roofing industry for 50 or 60 years. So they can be expected to have a life equivalent to the roof. And you don't ever need messy field applied caulking. More is not better. Please don't goop caulking on top of these parts, because any surface applied sealant like that is not going to last. The third mounting method then is called direct mounting or direct attach, which is a term trademarked by S5 many years ago. Direct attach is gradually becoming the norm for metal roofing, and that's because whether it's standing seam or face attached profiles, they all have built-in rails. They all have this thing in common. They have built-in rails that are integral to the profile of the roof panel. And they're quite convenient for solar mounting. And there are plenty of them, and they're free. Common standing seam spacing is between 12 and 24 inches. You may occasionally run into a seam spacing that's either side of this window, but it would be very occasional. In the case of exposed fasten profiles, the rib spacing is normally 6 to 12 inches. So you have even more rails available inherent to the roof profiles on exposed fasten. So using the rails that are already there, that are plenteous and are free, all it's needed now is some widgetry, that's a technical term, that marries the module to any S5 bracket or clamp, which is then in turn mounted directly to those rails or roof seams or ribs. So we've recently introduced, recently being within the last 2 years, the Generation 2 S5 PV kit. What we did was we took every annoyance that we heard. We do stay in touch with our customers and we communicate with them pretty regularly, and we actually listen. And we took every negative thing that they found about our Generation 1 PV kit and eliminated all those things and improved it quite a lot. So one size still fits all modules, as with the 1.0 version, but now the top surface of the grab is pretty much flush with your modules. So there are no projections that stick up very high above the module frame, maybe a 1/4 inch or something, as you see there. This PV kit fits to any S5 clamp or any S5 bracket for both standing seam, therefore, as well as through fastened or exposed fastened roof types. It's listed for electrical bonding in accordance with UL 2703. And these components have survived Cat 5 hurricane winds down in the Keys in the Caribbean. And they're all non-corrosive components. So what more could you want? Well, just in case you wanted more, here's a little more. The mid grab can also be used at the edge condition. So you don't have to order edge grabs. If you don't want to, you can order all mid conditions. They're the same price. The PV kit comes pre-assembled, not pre-assembled to the clamp, but the components that you see from the clamp and up are pre-assembled. It accommodates frame thicknesses of 30 to 46 millimeters. It's all aluminum and stainless steel. You have an automatic ground path through that PV disc, as I just mentioned, according to 2703. You use the same tool for fastening the clamp to the seam as you use for attaching the PV kit to the clamp. So it's quick and easy installation, and note that last bullet point, it is also, as of recent, available in black. You have in your handouts some links or PDFs, and on those PDFs you'll see this link. I'm not going to play this in its entirety. It's a how-to video for the PV kit, and it lasts about 7 or 8 minutes long. So what I have done for this presentation is I've edited that thing down and speeded it up a little bit to get it down to about 3 minutes. And I'll just kind of go through some of the points as you watch this video. So installing the first row of clamps, the starting row, it's important that it's very true to line because everything is based from there. You see them now attaching the PV edge kit by hand and then tightening it down just a little bit, but leaving it loose enough just to hold that module in place so it doesn't blow off the roof. And here you can see that he's using the module as a spacer tool, installing the next clamps at the top side of the module, and those will be left loose just a little bit as well. And he's explaining there why they're left loose so that you can bump them around and adjust them and get them aligned just right before you do your final tightening. So you'll repeat that procedure from starting at the bottom. Normally you could start at the top, but it's a little easier to start down at the eave and work your way up. And then when you've got the whole column installed but not tight, you align them to your satisfaction and tighten them down. And then move on to the next column of modules, that is. What he's telling you here is before you go home at the end of the day, if you haven't finished that column and you've left it loose, make sure to tighten it down in a few places so you don't lose your modules in a windstorm. And he's also explained there at the end, you saw the space between those module columns. Normally you would buddy up at minimum, that space was left intentionally to create a walk space, and that's what he was demonstrating there, so that you can access any module on the roof if desired. Normally, though, you would buddy up 2 module columns, and then you'd just leave a walk space on either side of that pair of columns. But that's an option. You don't have to do that. It's kind of optional. Direct attachment in this fashion maximizes economy, but occasionally with a small space loss. You're seeing here the ground path. I'm going to come back to the space loss. You see the ground path here from module frame to module frame through that patented disc. It's got little scratcher teeth on it so that it breaks through the anodization coating on the modules to establish a ground path. No need for jumper wires here, except perhaps to connect one column of modules to the next column of modules. No need for additional components, weaves, or anything like that. So here we see an example, and this is about a worst case of space loss. It's 7%. On this particular job, you see how long this roof was. And in this case, they wanted access paths, and they had plenty of roof space. And so this was actually a customer preference that they be able to access any module on the roof at any time. And they left these spaces between modules and lost about 7% of the usable roof space. But as I said, it was a customer choice, and they had plenty of roof space. You'll also notice here that these modules are attached at 6 points. Normally, only 4 points. That'd be 2 points on each side of the module, and of course they're ganged together, so that each one would be attached in 4 spots, which is common in the solar industry, as I'm sure you know. But in the event of increased wind pressures in certain zones of the roof, or increased wind speeds in places like the Florida Keys or the coastal Florida, hurricane zones in the Caribbean, you have more rails available to attach to than you have to attach to. So in those kind of wind environments, they're there and you can attach to them and increase the wind resistance of your finished array. Conversely, here we see this project in southern Germany that's using 4 points of attachment, which is more normal, and the space loss is less than 1%. You can see a 1% space loss really isn't a space loss. I don't think another column of modules could have been fit on this roof, such as in this case at Fort Dix. If you look closely at that slide, I don't know if you can see my cursor here. You have a little correction gap here and here. Every 7 columns of modules, you have a little correction space, and that's there for thermal expansion relief as well. But if you add all that space was only about 4 or 5 inches wide. If you would add that all up 6 times or 7 times, however many times it occurs here, you still wouldn't be able to get an extra module column on this roof. So it's really a 0 space loss. This one in Puerto Rico, right in between, about a 5.5% space loss, and this one using 4 points of attachment as well. This was on a face attached roof, as you can see. An interesting question that often comes up, when we talk about direct attach as opposed to rail attachment, is this question. Well, my rails are putting the glass much higher in some cases than your direct attach methods, and I'm worried about optimal airflow to keep the modules cool so that they're more efficient and so on. So this is a valid question. What clearance dimension is really required for optimal airflow beneath the module? Now, if you ask a module manufacturer, he's going to tell you, well, more is better. So whatever. Try to give us at least 6 inches, but more is better. Well, the module producer doesn't have a hound in that hunt. He doesn't care if you spend an extra 20 cents a watt to get a module up high. He just knows that higher is better. There actually is no improvement in the cell temperature once you're 4 inches above the roof. You could hang it on a pole at 10 feet high, and it would not be any cooler than it is 4 inches off the roof. In fact, that's exactly what was done at a Department of Energy Los Alamos research project. They hung one on a pole as a control sample, and they measured the performance difference, which is directly related to module temperatures, at 2 inches, 3 inches, 4 inches, 5 inches, and 6 inches. And there was no change from 4 to 6 inches. And the change from 3 to 4 inches was only about 3.5%. We've also concurred with those findings from simply measuring module temperatures side by side on modules at the S5 branch from 4 and 6 inches. And there's absolutely no temperature difference whatsoever. In fact, in some cases, we might have measured 1 degree hotter at 6 inches than at 4, and the next day or a week later it might have switched, but most of the temperature readings we got were absolutely identical in both cases. And in fact, there is a downside to putting more space beneath the modules because it aggravates wind uplift effects on those modules. So with very limited exception, our mounting solutions are all designed to place module glass at least 3.5 inches above the flat plane of the roof. I'm not referring to the standing seams, but to the flat part of the roof. And in most cases, we exceed that. Here's an example in cross section. This seam height, standing seams are typically 1.5 to 3 inches in height. So that dimension is going to vary from roof to roof. The mounting hardware adds another 3/4 of an inch or so, and then the module frame another half. Clamp to seam type hardware and PV kit. When you look at our direct attach for face fastened roofs or exposed fastened roofs, one thing you'll notice, we'll get to the dimensioning here in a minute, but one thing you'll notice is that we always try to attach to the slanted wall of the rib as opposed to attaching a simple part to the top of the rib. And the reason for that is it puts those fasteners under wind uplift pressure. It puts those fasteners in shear rather than in direct pullout. And their holding strength in shear is exponentially more than their holding strength in direct pullout. You can see there also the features and benefits to the right. Factory applied EPDM seal. We create a cavity there within that part design so that the seal is not over compressed. And then you've got 4 fasteners in shear. So you have a lot of redundancy in this part. And we use a factor of safety of 3 here for from our ultimate tested loads to what we consider the allowable loads for the part. And these parts will easily achieve that and deliver in excess of 200 pounds allowable load in most gauge roofing materials. You also, that channel there can be used for wire containment. You have infinite north-south adjustability here because you're mounting it anywhere along that rib that you want to. Swarf is drilling debris that can, because we don't use a drill fastener, we use a self-piercing fastener. So it eliminates any drilling debris on the roof, which can tend to rust and stain the roof. Coming back to the dimensional things, you see that generally speaking, you have at least 4.4 inches when using this part with our PV kit. And we already saw this part when applicable to rail mounting. The Protea can also be used for direct attach methods with our PV kit. And that's what you see being illustrated here. Similar sort of principle. This part is very, very versatile. It'll fit almost any rib size up to a 3-inch wide dimension across the dimensions that vary on these profiles. If you can follow my cursor, this dimension across the top of this rib varies quite a bit. The angle here varies to some degree as well, and the rib height also varies. But this part fits ribs up to 3 inches wide. As I pointed out before, it can be used for rail attachment, it can be used for direct attachment. It's really a cool and nifty part. It's very versatile, but it is more expensive than some of the other options. It's one of our most popular parts, however. We even have mounting brackets for corrugated metal roofing. Now, this is another type of exposed fastener roof. The corrugated, the sinusoidal wave effect that you see there. Many in the industry call anything with a rib corrugated, and that's not technically correct. You're looking at a corrugated profile here. The others are trapezoidal rib profiles. But even on our corrugated profile, which has a very low corrugation height, we're putting glass 3.8 inches above the roof. Now, when you consider direct attachment, it requires a shift in your thinking. When you're rail mounting, the modules are always installed 90 degrees to the rail. That puts them in portrait orientation to the roof. With direct attach, modules are still 90 degrees to the rails, but the rails have now become the roof, which puts them in the other axis or landscape orientation. I want to show you something about cost. That's a disclaimer. You can read it. It says, you know, go job by job and make these comparisons. But we took a project. The project criteria is listed here, and we compared the cost of the two options side by side: rail mounting with S5V clamps and PV kit mounting direct attach with the same. Here you see a schematic of the rail attachment, and here you see a schematic of the direct attachment. What we want to look at is the total costs involved here. I'm going to flash them up real quick, but you can see the breakdown and the total cost figures there, cost per watt. And the direct attach mounting system saves 53% of the total cost in this case. Let's look at some other factors. Of course, cost is always a driver, but there are some other benefits as well. The weight of the rail system was 970 pounds. The weight of the S5 direct attach system, 149. That's added load of only a fraction of the added load of the rail system. And that fraction is actually 15%. So direct attach is 15% of the weight of the rail system. And the points of attachment are actually increased, both requiring the same roof space. When you think about the weight thing, think in terms not only of the weight on the roof structure, but of transportation costs and material handling logistics, both to the job site and once there, unloading from the freight carrier, finding a place to stage it at your shop, reloading onto the headache rack of a service truck, unloading at the job site, handling those rails up to the roof, staging them on the roof and layout and so on, not to mention field cutting to length as may be necessary. Look at the weight and the physical size of S5 direct attach components. You can forget the service truck. You can put all these components in the trunk of your Mini Cooper and head up the ladder with a 5-gallon bucket for a system size of 8 to 10 kW. Then that bucket's going to weigh 25 or 30 pounds. You're also providing more uniform load distribution into the roof because you have 25% more attachment points than with a rail mounting. So why is S5 the right way? Well, it's not only for the reasons you've just seen, but we have attachment solutions for everything on the roof, including wire management, combiners, inverters, service walkways, fall protection, other roof mounted equipment, weather monitoring equipment. Another reason why S5 is that we have a 27-year history and over 2 gigawatts of successful PV installations without a single documented failure, and a 25-year warranty on all our components. We know something about compliance standards and code approvals. In fact, we helped to create many of them. We know something about metallurgy and galvanic compatibility and fastener compatibility. And we know something about corrosion testing. We've done all kinds of corrosion testing. Here you're looking at a typical example of an ASTM B117 corrosion test after 1,000 hours at a clamp location, and here after 2,000 hours. We know all about tensile load testing, and we in fact created the protocols for tensile load testing of clamp on seam back in 1992. Notice the load there before failure of 2,100 pounds. And you can find all that data published right on our website. We've published mechanical load test data from over 3,000 individual pull tests on 500 roof profiles in all different seam geometries and material thicknesses and material types. And full lab reports are available for any of those on request for engineering purposes. We've earned metal roof system manufacturer because we've performed all our due diligence. We've earned metal roof manufacturer recommendations and approvals. And we've also have the endorsement of many industry professionals, in fact, industry icons. This guy is the guy that invented galvalume coating for steel sheet. This guy is the guy that invented the PPA, Jigger Shaw. He's the co-founder of Sun Edison, and he got out, fortunately, before they met their demise. We manufacture in-house for total quality control. We're not content with anything less than total quality control, and that's why we do our own manufacturing in a state-of-the-art 42,000 square foot facility. And we're visited regularly by all these agencies. They drop by unannounced to make sure that we're following all the quality protocols that earned us those certifications. Perhaps one of our greatest assets is quality people. And we have right now about 65 on staff, and some of those have been with the company for 10 and 15 years, even some of them over 20 years. So we're the metal roof experts. We have the track record, the warranties. We're 100% made in the USA with roof manufacturers' endorsements, and so on and so forth. Large brands use us because we have the technical know-how and the track record and documentation to prove everything we say. Small users and homeowners use S5 because we're reputable and we're very affordable. We should know things about solar and metal roofs that no one else does. It's where we came from, and it's who we are. And we do know. It's just the right way. So that wraps up the presentation. I'll be happy to take some questions if you guys have them. I don't see any questions on the webcam sheet here. Any questions? Don't be bashful.
Hey, Rob, this is Michael speaking again. It looks like we're having some question difficulties. What I would ask is for people to email questions to me at Michael, M-I-C-H-A-E-L, at CivicSolar.com, and I will relay the questions to Rob, and then we'll get back to you with answers. It looks like potentially there were some questions being asked, but it looks like there's an issue with the questions showing up for everyone to see. The other thing is that with this presentation, there are NABCET continuing education credit that is included. If you are interested in receiving that, please email me, Michael, at CivicSolar.com, and we will work with NABCET to get you your certification for the continuing education credits. I would like to just thank Rob personally and on behalf of CivicSolar for such an outstanding presentation. It was a real treat to hear firsthand about S5 and your solution that you provide. Thank you very much, Rob. I'll let you finish up.
If you'd like to contact S5, the web address is there on that slide. It's simply s-5.com. If you want to contact me personally, just put a Rob, R-O-B, at in front of that address, and you can get me personally. You can come on our website if you'd like to get added to our database so that you have new product announcements and things like that. We won't bug you with an enormous amount of junk mail, but once a quarter or a little more often, we may send you a newsletter with new product announcements. So thank you very much for attending. Thank you, Michael, for hosting this webinar, and we look forward to further communication.
Thank you again, Rob, and thank you for everyone for attending. Have a wonderful day.